All right, welcome to The Explainer. Today, we are going deep under the hood of what might just be the biggest leap forward in AI, autonomous agents. We're moving past AI that just gives you answers. We're going to break down the blueprint for AI that can actually do things on your behalf. You're probably used to AI that works a bit like a super smart search engine. You ask a question, you get an answer. But what if it could go a step further? What if it could actually act on that information? Plan that whole project, book the flights for you, and, get this, learn from the experience all by itself. Yeah, that's the really powerful idea behind these LLM agents we're diving into today. And this right here, this really shows you the fundamental shift. So on the left, that's the AI most of us know, right? It's passive, it just waits for us to tell it what to do. But the agentic model on the right, that's totally different. It's not just an assistant anymore. It's an active collaborator that can perceive its world, reason about a goal, and then, take action. It's a huge leap, really. We're moving from just having a tool to having a teammate. Okay, so how do you actually build one of these things? Before we get into how they work in big, complex teams, we've got to understand the individual player first. So let's start there, with the blueprint for a single agent. It really boils down to 4 key parts, 4 pillars that are all connected. I like to think of it kind of like building a person. First, every agent needs a profile. That's his personality, its job description. Then it needs memory, so it can actually learn from what it's done. It absolutely needs a way to plan, to figure out, okay, what do I do next? And of course, it has to be able to take action out in the real world, or, the digital world. You get those 4 things right, and boom, you've got the core of an intelligent agent. So let's look at that first pillar, the profile. This is basically the agent's identity. It's the job description and personality rolled into one. It sets the rules for how it's supposed to behave. And this is cool. You could say handcraft a very specific profile for a master coder agent, or you could automatically generate thousands of different profiles to simulate an entire digital society. Okay, next up is memory, and this is absolutely critical. So agents have short-term memory, which is kind of like the RAM on your computer. It holds all the context for the immediate task at hand. But here's the game changer. They also have long-term memory. This is where they can file away experiences, successes, failures, and turn that into knowledge they can use later. It's exactly how they learn not to make the same mistake over and over again. All right, so an agent's got its profile, it's got its memory, but how does it actually figure out what to do? How does it plan? Well, the simplest way is basically a to-do list. It just goes through one step after another. Plan and solve. But a much smarter approach is something called the tree of thoughts method. Here, the agent actually games out multiple possible futures at once, exploring different paths and backing up if one looks like a dead end. And then you've got the most advanced planners. These guys actually learn from their own actions, constantly tweaking their strategy based on what's working and what's not. So a single agent is powerful for sure, but the real magic, that starts when you get them to team up. So how do you actually organize a whole group of these agents to tackle problems that are way too big for any single one of them to solve alone? The first way to do it is pretty classic, a top-down hierarchy. You have a single boss agent. Think of it like a project manager. It takes a big problem, breaks it down, and then delegates the smaller tasks to these specialist worker agents. And then it pulls all their work back together at the end. This is the kind of setup you'd want for really high-stakes work, where you need tight control and reliability. Like automating experiments in a science lab. Now, the other way to go is a decentralized approach. Here, there's no single boss. You just have a team of equals. The agents talk directly to each other, figuring out how to solve the problem together. This model is way more flexible, and it's perfect for simulating really dynamic, unpredictable situations, stuff like modeling how human societies interact, or for just brainstorming really creative ideas. So, which one's better? The boss or the team of equals? Well, as you can probably guess, it's a classic trade-off. The centralized model, the hierarchy, that gives you tons of control and reliability. But the decentralized, peer-to-peer model, that's where you get flexibility in that amazing, unpredictable creativity. So the real question for anyone building these things is, what are you trying to do? Are you building an assembly line? Or are you trying to host a brainstorming session? Okay, this next part is what I find really fascinating. How do these agents, whether they're working alone or in these complex teams, how do they actually get smarter? How do they evolve and improve over time? Well, it looks like there are three main ways they can level up. First, they can learn all on their own. They can basically coach themselves by reflecting on their own work. It's called self-refinement. Second, they can learn from each other. They co-evolve either by working together or by competing. And third, they can learn from us and the outside world by tapping into external resources, like searching the internet or plugging into a specific company database. Let's zoom in for a second on that idea of learning from each other, that co-evolution. Sometimes agents learn like teammates on the same side, cooperating to reach a common goal. But other times, and this is really clever, they learn like rivals. You can actually set up agents to debate each other or have one agent red team another's solution, meaning it actively tries to find all the flaws. And that kind of competitive pressure, it forces the whole system to get smarter, tougher, and more robust. It's brilliant. Okay, so we've gone through all this methodology, the profiles, the memory, the teams. Why does any of this matter? Well, it matters because it's already powering some incredible real-world applications. But it's also bringing up some very, very real challenges we need to talk about. Take science, for example. Agent systems are already being used to design and even physically run experiments. There are frameworks out there that can actually plan out complex chemical syntheses on their own. Others are helping design brand new materials. We're talking about a massive speed up in the pace of scientific discovery. The gaming world is another area that's being totally transformed. I mean, just imagine non-player characters, NPCs in a game, that don't just walk along a pre-programmed path. Imagine they have their own goals, their own memories, and they react dynamically to your actions. That's what agents are doing. They're making these game worlds feel alive, way more immersive, and almost endlessly replayable. And then there's productivity. For businesses, for developers, this is a huge game changer. There are already entire teams of agents out there that can take a simple idea for a piece of software and then autonomously write the code, debug it, and test it. This is automating workflows that used to take whole teams of people weeks or even months to get done. Now, this all sounds pretty incredible, right? But let's be real, the technology is nowhere near perfect yet. So what are the major hurdles? What are the big problems that researchers are trying to solve right now? Yeah, the hurdles are pretty significant, and you can really boil them down to two big categories: resources and trust. First, scalability. That's a resource problem. These agents take a ton of computing power to run, especially in large groups. Memory is another one. Their context windows are still limited, which means they can forget key details in the middle of a long, complex task. Then we get to the trust issues. Reliability is a huge one. You can't have an agent making stuff up, hallucinating, when it's handling a high-stakes decision for your business. And finally, evaluation. This is a tricky one. How do we even know if they're doing a good job? Our old benchmarks, our old tests, they just weren't built to measure this kind of dynamic, collaborative behavior. So how can we trust them if we can't even properly test them? Ultimately, and I think the researchers who did all this work put it perfectly, the goal here has to be responsible advancement. The progress we're seeing is just stunning, no doubt about it. But solving these challenges, the resource problems, the trust problems, that is the absolute key to safely deploying this tech, which, let's face it, could totally reshape our world. We're not just building smarter tools anymore, we're actually building our future collaborators. And I guess the big question that leaves us with is, are we ready to work alongside them? Thanks for joining us on The Explainer.